Okay, hello, this is Professor Elliott, and in this lesson we will look at the 74LS93 counter. So this lesson follows our previous discussions on the 74LS 76JK flip-flop counters. And as you'll see, essentially what is internal to these counter is just JK flip-flops. So the focus of this lesson is to show you how the chip is arranged internally and how you can make use of the connections and the various options that are provided for you. So if you're thinking about your project, which I'm sure most of you are, the 93 counter will make your wiring much simpler. However, you don't have the flexibility in order to to um, to do any more advanced features. So in other words, if you're trying to get the extra sort of bonus marks, it's going to be difficult with this counter alone because it doesn't have the options. Where the JK flip-flops, you can manipulate the set and clears to do all kinds of neat things. So anyway, let's get started, okay? I'm going to switch to a different view. It's going to make the screen smaller, so I apologize for that. However, it will make it possible for me to type some notes as we're going along. So I think that's worth the trade-off. Okay, so I'm going to click on here. Okay, so you can see we have a fairly small screen here, but I can add notes as we go along. So I'll try to type a lot here with what I'm saying, and hopefully between the two, you'll get all the information. Okay, so here we go. Okay, so this is from the data sheet, and the data sheet, the full PDF I provided for you online. But anyway, here's some highlights of that. So first of all, you'll see that this one data sheet does covers different part numbers. Okay, so you have to, and that's just for an efficiency thing from the manufacturer point of view. So it covers the 74LS90, the 92, and the 93. So we want the 74LS93. That's the one that we want. Okay. You can see here it gives you the package description. Okay, a little picture. The D suffix, that means it's a surface mount device, so it's going to be soldered on the circuit board. The N or the J, they're both through holes, again, to be soldered on circuit boards. The J is a ceramic package, so it's more higher duty, but it's going to cost more money. But anyway, okay, so over here, you should read this blurb. It gives you a description of what each of the counters do, and you really need to get familiar with that. If you ever, designing some circuits on your own, you have to get all your information from the data sheet, so you need to kind of learn how to interpret it. Okay, down here, there's the pin names and the description, so that's very important. So keep that in mind as we go through. Okay. Okay, so next slide. Too far? Yeah. Okay, so this provides the functional description, and it gives you sort of a summary up here at the top, and then it breaks it down into the LS90, 92, and 93. And you will see that the LS93, that's where the red arrow is, it can be used as a 4-bit ripple counter or a 3-bit, depending on how you connect it. Okay, again, that sort of summarizes the key connections. So take a note of that. So this is the schematic symbol. I'm going to go back to my notes here. So it has 2 clocks. Okay, so two clock inputs. Okay, so they are CP0 and CP1. They are falling edge triggered. Okay, and you have to decide which one you are going to use. Okay, so use only one. So you notice that there's an AND gate. That AND gate is internal. Okay, and you'll see that on the next slide. Okay, that's used for the reset. So MR stands for master reset. Oops. And that's going to be used if we need to prematurely reset the counter, just like I've showed you in class before. Okay, so notice the pin connections are on 2 and 3. Okay, so the outputs. Okay, so they are Q0 all the way to Q3, so that equals 4 bit. And you'll see you don't have to use the 4 bits, but it's up to 4. So the max count, okay, is a mod 16. So this will count 0 to 15. Okay, and it only counts up count only. It does not do a down count. Okay, take note the power connections. Okay, VCC is on pin 5 and ground is pin 10. Okay, so don't wire it like you would a normal gate. Okay, you'll damage the chip. All right. Okay, so all these are just screenshots from the data sheet. So here we have the pin layout on the right, and so you see CP1, MR1, MR2. NC means no connection. Okay, that means there's no functionality there. It's just a dead pin, so you don't have to do anything with it. So that applies to pins 4, 6, and 7. So no connections to pins 4, 6, and 7. Okay, so just leave them as is. All right. Okay. Note VCC and ground. Okay. All right. So if you look to the left, you'll see the internal structure of the counter, and you can see it's just simply JK flip-flops internally. And you can see that clock input CP0 comes into pin 14, and it goes into that first flip-flop. Okay. Clock input CP1, which is on pin 1, goes to the input of the second flip-flop. So I need you to see that we have a single flip-flop with its input on 14 and its output on 12. And we have a group of 3 flip-flops, which with its input on 1 and its output on 9, 8, and 11. Okay, so if you're going to use 3 bits only, you can simply abandon CP0 on pin 14 and bring your clock input to CP1, or you can connect pin 1, okay, which is the clock here, to pin 12. So you're just joining the single flip-flop to the group of 3, and then bring your clock into pin 14, then do a premature reset. Okay. So let's put a note here. So depending you may choose to use all for flip-flops, bits, or just the group of 3. Okay, you can see because this is all internally connected. Okay, so connections internal. Oops. So that leads us then to, okay, easy external wiring, but with limited flexibility. Okay, so all right, next slide. Okay, so I've just simply, this is simply the same slide. I've just highlighted the internal structure, so we've already covered that. So let's just go on. Okay, so let's look at a mod 6 counter, which will up count 0 through 5, and it always resets on 6. Okay, basic schematic. Some notes. Okay, so mod 6 counter, count 0, 1, 2, 2, 5, reset on 6. Okay, so here, because we only need 3 bits, I've chosen to abandon CP0, okay, use CP1 as the clock input. Okay, that's just to keep the wiring as simple as possible. Yes, we could have used all 4, but we would have had to then still do the reset, so we don't really gain anything by doing that. Okay, so I want you to take notice of the NAND gate. Again, this is internal. Reset connections. Okay, so when the count reaches 6, so we can say at count of 6. Okay, outputs Q1 and Q2 are high, therefore use them to reset the counter. Okay, so that's the first time that those 2 bits have gone high together. Okay, so using that, we just tie them back to the MR1 and MR2. Okay, so tie into MR1 and MR2 as shown. Okay, notice how I've just relabeled the outputs. Okay, because Q1 is now becoming Q0, and Q2 and Q1 and Q3 is Q2. That's because we're using the 3, just a group of 3 instead of all 4. Okay, all right. Okay, mod 10, and how to connect to a 7-segment display. Okay, so mod 10 counts 0, 7, 7, 8, 9, then 10 and reset. Okay, so we can say then the valid counts are 0 to 9, resets on 10 for the start of next count cycle. Okay, so if you're using the segment display on the trainer, the decoder is built in. So the 74LS47, it's called a decoder driver, is built into the logic trainer, with the note that we cannot promise they are all working. Okay, so anyway, so they're there. If they're working, great. If they're not working, we can't easily fix them, so you're going to be kind of stuck. So, but they should be okay. But anyway, that's just a caveat. Use them at your own risk. Okay. You are welcome to purchase the 74LS47 from NewTek or Sayal. There are two nearby suppliers if you want to do some wire them externally, which would be a good experience for you. And again, I was doing that back in high school, so it's not a big deal. Okay, so anyway, so the decoder acts as the interface between the BCD counter and the 7-segment display. Okay, so it activates the appropriate LED, and that's all they are, LED segments to display the corresponding count. Okay, all right, so this is a complete schematic. So you want to use a TTL clock only, okay, not a sine wave, or you would destroy the counter. Okay, right? So adjust the frequency so as to be able to see the counter count on the display. If you set the frequency too fast, it's going to count so rapidly your eye won't be able to pick it up, so you can just easily play with that. Okay. All right. Okay, so again, this is just continuing on. So the LS47 decoder accepts BCD counter inputs to interface to the 7-segment displays. Okay, note that the outputs from the decoder, so decoder outputs are active low. Okay, that means they have bubbles. Therefore, they must connect to a common anode segment 7 display. Otherwise, it's not going to work. Okay, if you're using a common cathode display, you need to get, I believe it's the 74LS48 with active high outputs. Okay, so anyway, make sure you get the right match or it won't count. Okay, and in the LEDs need current limiting, so the resistors provide current limiting to the display LEDs. Okay, mod 16, basic schematic. Okay, so mod 16 counts 0 to 15, reset on 16. Therefore, we need to use all 4 counter bits. Okay, so look at the schematic. Okay, so we're going to connect CP0 to the clock TTL source, and there we're going to connect Q0, which is pin 12, to CP1, which is pin 1. So in order to connect the group of 3 flip-flops to the single flip-flop. Okay, this is needed to utilize all 4 counter bits. Okay, and because then we're using the full counter capacity, it will naturally roll over. Okay, so therefore we do not need to reset the counter. Therefore, tie MR1 and MR2 to ground as shown. Okay, do not leave unconnected, otherwise you may get some unpredictable operation. Mod 100 counts 0 to 99, basic schematic. Okay, so the mod numbers multiply, therefore mod 10 times mod 10 equals mod 100, counting 0 to 99, resets on 100, okay, with all outputs going back. Well, let's just do that. Okay. Notice the output Q3 on the least significant digit counter, which is i.e. the 1 tied to the clock. Connects to CP0 on the next counter section. Okay, so when Q3 goes high to low, this provides the falling edge clock for CP0. Okay, so basically when the counter on the left, which is the least significant counter counter section, when it counts to 9, rolls over to 10, Q3 goes low, it provides the clock pulse for the next counter section. Okay, so every time the left hand mod 10 cycles through, the right hand mod 10 increases by 1. Okay, and you can have a look at that, but that's exactly what happens. Okay. Okay, segment display. Okay, and most of this is also in my professor notes, which I'm sure you've figured out by now. Okay, so see my professor notes as well. Okay, so by using the 74LS93, we can easily create 2 mod 10 counter sections. So we can say then that the clock connects to the first, the least significant digit mod 10 counter, right, whose MSB provides a falling edge clock for the most significant digit mod 10 counter, which is exactly what I described on the previous slide. Okay. All right, so this is a complete schematic. Okay. Okay, so this provides a little more information. The most significant counter I'm showing in blue, and the least significant I'm showing in purple. Okay, so note the falling edge from the I'll show over here where the falling edge is. That's how the two counters interconnected. Okay, so anyway, have a look at that. Okay, troubleshooting. So I guess this is our final slide. So here we have a 74LS93 counter, and we are only using three bits here. So it's supposed to count 0 through 0, 1, 2, 3, 4, 5, 6, and then reset on 7. Okay. Not quite sure why I showed the Q1 on the left side instead of on the right, because that's the LSB. But anyway, that was a long time ago. But anyway, so if you look at the count sequence, this is saying that you wire it up and you see the count sequence, instead of being sequential, it's running 0, 1, 4, 5, 2, 3, 6. So obviously there's a problem, right? And if you look at the table here, it looks like connections Q2 and Q3 have been interchanged. So just have a look at that. I may or may not test you on it. I haven't done it for a number of years, but you never know. But anyway, you can logically work that out. Okay. So I guess that's the end. I hope you've enjoyed the presentation, and feel free to contact me in person or email or whatever if you need some more guidance or questions answered or anything along those lines. All right, so have a wonderful day, and hope this was beneficial and at least somewhat interesting. All right, okay. Cheers. Bye bye.